Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at storing your static link library files in a Power library. In this series of videos I'll be covering the creation and use of libraries. So you might ask, why use libraries? Why not just write code whenever you need it? Well, if you're writing a lot of applications, having common libraries that contain functionality that you use often will save you time, both coding and testing. It will also make your code more readable and therefore maintainable, which is always a good thing. We have in the majority of our videos used libraries of one form or another. Many of these libraries have been include files, which have been included in with the main basic application code. For example, in this application we see before us, there are two include files, one for the Windows 32 API include and one for the common display include. At compilation time, the PowerBasic compiler compiles the code within these libraries inside your application to produce one single executable. We have also in previous videos covered the creation of a static linked library and a dynamic linked library. The dynamic linked library creates a file which has the extension DLL. In this DLL file, your functions and subroutines can be either internal to the DLL or they can be exported so they can be declared within your main code. A static link library is slightly different. A static link library is a file with the extension SLL. This file contains pre-compiled code and can be linked in with your application by the use of the link command. Using SLLs is quite useful as it produces a file which can be passed on to other developers without having to give them the source code. As it's pre-compiled, PowerBasic will take the functions or subroutines within this file and include it in your application. So if you have created a number of static link libraries, they can all be linked into your code. We will demonstrate that first of all by creating and using 3 static link libraries. The source code for this advanced libraries.bas file is held within this source apps folder. In the directory above, I've created 2 additional folders, an SLLS folder and a PBLibs folder. We're going to create 3 static link libraries within this SLL folder. First of all, we're going to create a subfolder called taxlib. This is going to be a container for a library which is going to handle tax routines. So we will create a very simple static link library file. The first line of code is to compile it to an SLL. And we've created a simple function called return VAT tax. It takes one parameter, which is going to be a currency X. And we're setting this function to export as currency X. This means the function within our static link library will be visible to code outside the library. And this function is merely taking the input amount and multiplying it by 0.20 to give us 20% of the value that's been passed in. If we save this file, and we'll call our code in here vat.bas. And if we do a compile on that, it will compile quite cleanly. And if we have a look inside the folder, we will see that we have a vat.sll file. This is the compiled code of this function. If we wish to make use of this static link library within our code, we can use the link command. The link command is going back one directory, into the SLLS directory, into the taxlib subdirectory, and it's accessing the vat.sll. Having done that, we can now call that function within that library inside our code, simply by calling the name of the function. No declaration is actually required. We're giving it one value, and the return from this function, and we're printing that out to our console. If we try compiling now, we'll see this will compile quite happily. If we double click on our application, we will see it will print out to the screen the value added tax on £120.45 is 24 and 9. So we have successfully compiled a static link library and we have linked that in to our main code. The whole point of libraries is to make it easier for your future coding. If you have subroutines or functions that are used on a regular basis, they may as well be in a library. We have also in the past created a static link library to do random routines for generating random data. I'm going to link this one in as well. I've created another subfolder called randomlib. In here we have the source code and the static link library for our random routines. So again, we can call this getTelephone function from within our main code by simply including another command to link in our library. And then we can call the fun getTelephone function from inside this code. If we compile that, and we run our application again, we will see not only does it generate the value added tax value, it gives us the random telephone number as well. So as we have seen, it's very easy to add static link libraries using the link command to your main application. This way you can build up a series of these libraries which contain code that you will use all the time. I've now added a third static link library, FileHandleLib. This contains all the code that exists within the file handling routines library. And again, what I've done to convert this is quite simply to add the word export to the definition of each of the functions. And I'm going to set up three local variables, a headers, a delimiter, and a column name. Our headers variable is going to contain a delimited list of 4 values as being the headers of a file, being comma delimited. The delimiter is of course the comma, and the column name I'm looking for is the column number that the word telephone appears in, which should be the 4th column. We can now use one of the functions within that file handling library to do a parse find. This will look inside the headers variable using the delimiter and the name of the column we're interested in, and it will return the column number as a long. And all we need to do to access this is to put another link into the beginning of our code. So we've now added a third static linked library. If we compile our code now, go back to our executable and double click on the exe again. Our exe has now risen to the size of 68 kilobytes. And there is the column number being declared as being the 4th column in our string. So it's quite easy to add additional static link libraries. And you've probably used this technique yourself. These link commands, of course, could be in an include file, so that if you have the same set of static link libraries you want to include all the time, you merely have to add that include file. But what I want to look at today is the use of power libraries, which is a topic we have not yet covered. So how do we create a power library and what's it for? The power library is a mechanism by which we can take each of these static link libraries and add them to a single file. This single file can then be linked in to your code. So if we go up to our menu, you'll see on the Tools menu there is a PowerBasic Library Manager. If we click on that, it will ask you to either select or to create a new library. If we go into our PBLibs folder where we're going to place our libraries, and we're going to give our library a name. We'll call it First Library. And if we open that, it will tell us the file does not exist. Do we wish to create the file? This will bring a small dialog up on screen allowing you to add static link libraries to this first library. We click on the Add button and we can now browse and pick our static link libraries. We'll pick the file handling routines, the random library, and the final library, which is our tax library. So we now have these three on the screen. If we click the Save Changes button and OK that, if we look in the pblibs folder, we'll now see there is a pblib file of 18 kilobytes. This is the accumulation of the three static link libraries in a single file. So if we comment out each of these link commands and add a link command just to the pblib, if we compile our application now, it will compile quite cleanly. If we double click on the executable, which is 68K, the application will run quite happily. So we have successfully taken three static link libraries and put them into our first PB library. As you will see from the help file, there are one or two things to take into account when you start using static link libraries. We have added a single library, which comprises all three of these. And at the moment, our code is sitting at 68K. Say for example, we're not going to use the command to use parseFind. Therefore, although we have included the file handling library, we're not actually wanting to use it. If we comment that out and compile our application again, if we have a look at the size of the executable, we'll see that the size of the executable has actually dropped to 67K. So even though the pblib does include this static link library, when the compiler runs, compiles and links all the files together to produce your executable, the code that existed within the file handling routines SLL does not get included. If we comment this back in again and compile our application, we will see the size of the application has now gone back up to 68K. So you can quite happily add all of your static link libraries to the one Power library, and then use the functions you wish to within your main application, and any function that is not referenced, it will not be included. However, if one of the functions within the static link library is being referenced in your code, then all the functions will be included in your executable. So it pays to have your static link library files reasonably small and quite contained. There is no penalty in having a lot of static link library files, and you can let PowerBasic sort it out at compile time. The use of Power libraries is a step up from purely using include files and just using static link libraries, and allows you to do more planning in the design of your applications. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.